For this video, I want to talk about finding composite functions. So with these problems, we're no longer going to be evaluating composite functions at specific x values. Now we're going to take the entire function and plug it into the other function. So it can be a little bit messy, but let's just jump right into this example. So we want to find f of g of x. So g of x is our inside function. And for these, what I'm going to do is I'm just going to replace g of x by its entire equation. So instead of asking what f of g of x is, I'm now asking what f of 12 minus 5x is. And so in my function f of x, anywhere I see an x, I'm going to replace it with this entire expression. So like I said, these can get a little bit messy, but they're straightforward if you're slow and careful. So now plugging into our function f, again, anywhere I see this x, I'm going to replace it with this whole expression. So I have 1 over 8 times x, but x is now g of x, essentially. So I'm replacing x with 12 minus 5x, and then I have plus 3. And so from here, I can just simplify. So I have 1 over 8 times 12 would be 96 minus 40x plus 3, which is 1 over 93 minus 40x. So this right here would be your final answer. This is the composite of f of g of x when you take g of x and you plug it into f. Now, if you did it the other way, you would actually end up with a very different equation. So f of g of x, I just want to make this note, is not at all the same of g as g of f of x. So these are often very different equations. So you don't want to make that assumption. So if they asked this the other way, we would get a very different answer than this. So let's move on. So in this one, we're given our two functions, and we're asked to write h of g of x as an expression in terms of x. So we want to find h of g of x, and so we're going to replace g of x with this entire linear expression here, this 9 plus 4x, and then anywhere in h we see an x, we're going to replace it with this whole expression. So we really have h of g of x, but that's just 9 plus 4x. And like I mentioned, anywhere in h of x you see an x, we're going to replace it with this whole expression. So you have 9 plus 4x, and in general, when you substitute, it's probably a good idea to just put in parentheses, and that way if you have negative signs, this will kind of help keep everything organized. And then we have plus 21, and all divided by 5. So this was the x value in h of x. I just replaced it with g of x because we plugged g of x into this function. And now we simplify. So 9 and 21 makes 30 plus 4x, and then all divided by 5. So this is equal to h of g of x. And let's keep going. With these, you really just want a lot of practice. So with this one, we want g of h of x. So h of x, since it's closest to the letter x, that's going to be on the inside here. And h of x is this linear equation here. So I will replace it. G of h of x is the same thing as g of 10x minus 28. All I did was replace h of x with what it's equal to. Now I'm going to plug this in to our function g of x. So anywhere I see an x, I'm going to replace it with this entire expression. So I have 9 plus 4/5 x, but x is this thing, this 10x minus 28. So now I can simplify. So I have 9 plus, I have to distribute this. So I have 50 over 4 for that. So 50 over 4x. And 28 divided by 4 is 7 times 5, so you get minus 35. And 9 minus 35 would be negative 26. And 50 divided by 4 would be 25 over 2. And I'll just leave it as a fraction. But if you want to write 12.5x, that's fine too. So when we plugged in h of x into g, our resulting output function is this minus 26 plus 25x over 2, this linear function here. And let's do one final question. So this one is asking what g of f of x is. So since f is closest to our letter, we know f is the innermost function. And we're going to plug in this 6x minus 4 and replace it for f of x. So we really have g of 6x minus 4. And g of x is this quadratic here, and anywhere I see an x, I'm going to replace it with this entire linear expression. So this one will get a bit messy. There's a lot more simplification in this one. So we have 3 times x, but x is now this, 6x minus 4, and we're squaring it, minus 2 times x, which again is 6x minus 4, and then minus 10. So here we just have to simplify everything and multiply it all out. So I will rewrite this as 6x minus 4 times 6x minus 4, so we can multiply those binomials. Here I will distribute the negative 2. So we get minus 12x plus 8 minus 10. Now over here, I'm going to multiply these two binomials by distribution. So I get 36x squared for that one. And by minus 4, that'd be minus 24x. We do the same here, minus 24x. And then the minus 4 and the minus 4 make positive 16. And over here, I can simplify this just a little bit. Minus 12x minus 2. Now the 3 multiplies to all of these. So 3 times 30 is 90, plus 3 times 6 is 18, so that's 108x squared, minus 72x, minus 72x, plus 48, minus 12x minus 2. And one final simplification. So we have 108x squared, and then this is minus 144x, minus 12, so that's minus 156x. And then we have plus 48 minus 2, so that's plus 46. So like I mentioned, this one was definitely messy, but certainly doable. And let me just show you an example where we do it the other way. Like let's say we wanted f of g of x. Just so we can see what that looks like, so we can compare the two different functions and see that they're definitely not equal to each other. So this one, I'm replacing g of x with this quadratic, this 3x squared minus 2x minus 10. And so anywhere in f I see an x, I'm going to replace it with this. So that's going to be 6 times that quadratic, 3x squared minus 2x minus 10, and then just minus 4. So if we simplify that, let me just make a little bit more room. You get 18x squared minus 12x minus 60 minus 4, which is 18x squared minus 12x minus 64. And you do get a quadratic, but notice how different the numbers are with that quadratic and the other one right here. So this one was g of f of x, and this one here was f of g of x. So in most cases, they are usually pretty different from each other.